Good day, mathletes! We're now on the second week of Quarter 1 of Grade 10 Mathematics. At the end of the lesson, we're expected to meet the following learning competencies. First, determine arithmetic means. And second, find the sum of the terms of a given arithmetic sequence. Recall that an arithmetic sequence is a sequence of numbers with a common difference, meaning there's a fixed number added to the previous term to get the succeeding terms. Always remember that the general term of an arithmetic sequence, a sub n equals a sub 1 plus the quantity n minus 1 times b, is very important in our lesson for today, where a sub n is the n term, a sub 1 is the first term, n is the number of terms, and d is the common difference. Focus of our discussion is about arithmetic means and arithmetic series. Arithmetic means are terms between the two non-consecutive terms of an arithmetic sequence, whereas arithmetic series is the sum of the terms of an arithmetic sequence. Okay, to find the missing terms, we replace the last and the first term to the formula to solve for the common difference. So the common difference here is positive 4. So the first term is 4 plus 4 equals 8. Then continuously adding by 4 to get the remaining arithmetic means. Hence, the arithmetic means are 8 and 12. Next, we have 3 arithmetic means between 3 and 39. So, using the same formula, solve for the common difference p equals to 9. Then, continuously adding 9 starting from the first term. Hence, 12, 21, and 30 are the arithmetic means. Next, insert 5 arithmetic means between 10 and 40. 40 is the last term, 10 is the first term. And n is equal to 7, wherein there are 7 terms. Then solve for d, which is 5. So 10 plus 5 is 15, 15 plus 5 is 20, 20 plus 5 is 25, 25 plus 5 is 30, 30 plus 5 is 35. So these are called arithmetic means. Insert arithmetic mean between 2 and 52. Using the same formula, the last term is a sub n, the first term is a sub 1, and then 32 minus 2 is 30. Number of terms is 3 minus 1 equals 2. So 30 divided by 2 is 15. Then add 15 to the first term, so the arithmetic mean is 17. Aside from this formula, we can use the average of the first and the last term. So hence, the average of 2 and 32 is 17. What is the value of n in the arithmetic sequence? So it is applicable only if there's only one missing arithmetic. So just simply use the formula, just add the first and the last term, 5 and 5 then plus 10. So 5m, then 5 plus 7 is 12. Then the addition property of equality, then divide both sides by 5. So m is equal to 4.5. Hence, the arithmetic mean is 4.5. Insert arithmetic mean between 22 and 2. And solve for d, d is negative 10. So 22 is negative 10 and this positive 10. 12 is the arithmetic mean. The shortcut is only applicable if there is only one missing term. Next, to find the sum of the integers from 1 to 100, So we're going to solve for S sub n, which is 5050. But how? So first, we have arithmetic sequence from 1 to 100. Then the sum of the first and the last term is 101. The second term and the last is 101 also. There are 100 terms. Therefore, n is equal to 100. So replace all the known values in the formula to solve for S sub n. Confer the difference between arithmetic sequence and arithmetic series. Can you tell the difference between arithmetic sequence and arithmetic series? Arithmetic series is the sum of the terms of an arithmetic sequence. So we're going to use this formula S sub n equals to 2 times the quantity of A sub 1 plus A sub 2. So, to get the sum of the given arithmetic series, the sum is 125. So, the first term is 15, the last term is 25, and the value of n is 5. So, 15 plus 35 is equal to 50. 50 times 5 is 250 divided by 2, 105. How about the second arithmetic series? So, what is S sub n? So, since it's the multiple of 3, so the common difference is 3, and at the same time, the first term is 3. How many terms are there? So, using the formula to solve for n, we have 33 minus 10 divided by 3 plus 1. That is equal to 11. So, hence, there are 11 terms. So, S sub n is equal to 11 over 2 times the quantity of 3 plus 33. 3 plus 33 is equal to 36 times 11 equals 396 divided by 2 is 192. Hence, sub n is equal to 192. Let's find the sum of the first 5 positive even numbers. So we're looking for S sub n. So using the same formula, wherein n is 5, common difference is 2, and the first term is 2. But what about A sub n of the next term? So using the formula for the arithmetic sequence, to come up A sub n is 10. Then substitute the value of A sub n, A sub 1, and n. So 5 times 12 is 16 divided by 2 is 10. So therefore, A sub n is 15. So to verify, simply use calculator, add this number to the 30. Find the sum of all the 2-digit multiples of 10. So we're looking for S sub n. Then using the same formula, the first term is 10, common difference is 10, and the last term is 90. To get 90, we're going to use the formula A sub n minus A sub 1 over t plus 1. So n is equal to 9. So the given arithmetic sequence is starting from 10 up to 90. So 9 times 100 is 900 divided by 2 equals 450. So hence the sum is 450. Find the sum of all the numbers between 1 and 81 that are divisible by 4. So the first term is 4, the common difference is 4, and the last is 3. How many number of terms are there? So using the formula, so A sub n is 80, A sub 1 is 4 divided by the common difference 4 plus 1. So n is 20. Then plug in all the known values to the formula. We have S sub n equals 120. Next, find the sum of the first 25 terms of the arithmetic sequence 4, 9, 14, and 3. So A sub 1 is 4, common difference is 5, and the number of terms is 25. So what about the sub n? So A sub n is equal to 124. We're using the formula for A sub n. So we have 4 plus 124 is 158. Divided by 2 is 64 times 25 is 1,600. The first term of an arithmetic sequence is 3 and the common difference is negative 4. Find the sum of the first 5 terms. So A sub 1 is 3, the common difference is negative 4, and n is equal to 5. So substitute all the known values to solve for A sub n. So we have A sub n or A sub 5 is negative 20. Then substitute to A sub n, we have negative 25. Find the sum of the first 6 terms of the arithmetic sequence in which A sub n is equal to 2n minus 1. So you simply replace the value of n by 1, or n is equal to 1, so A sub 1 is 1. Then for the 6th term, for the last term, so A sub 6 is equal to 11, or A sub n is 11. Then plug into the formula for A sub n. So we have 1 plus 11 is 12, 12 times 6 is 72, divided by 2, 36. So the sum of the terms is 36. So to verify, we just simply substitute all the values of n from 1 to 6 using the given mathematical rule. A sub n equals 2n minus 1. So 1, 3, 5, 7, 9, and then 11. Then getting the arithmetic series, using your calculator, the sum is 36. Thank you for watching. Please do the remaining exercise.